In this video, we're going to talk about some more applications of using logarithms to solve exponential equations. So remember, we talked about continuous growth and decay equations back in our exponential functions unit. Remember, in our continuous growth and decay equations, our equations had a base of e because we were talking about continuous growth and decay. So now that we know about logarithms, we can solve these equations to find a missing value in the exponent. So let's look at this example. Janet opens a savings account with an initial deposit of $1,500. The account has an interest rate of 3% compounded continuously. After how many years will Janet have $3,000 in her account? So, since we're continuously compounding interest, we're going to use this formula. So, remember that P is the initial amount, so that's going to be $1,500. R is the interest rate, so that's going to be 3%, which I convert to a decimal. That is going to be 0.03. A is going to be the final amount she has in the account, so that's going to be that 3,000. So let's go ahead and plug everything into our equation. We have 3,000 equals 1,500, and then e to the 0.03 times t. Okay, so like when we're solving any other exponential equation, we need to first get that exponential term by itself. So I'm going to divide both sides by 1,500. So that's going to give me 2 equals e to the 0.03 times t. Okay, so now that that term is isolated, I'm going to go ahead now and take the natural log of both sides since my equation has a base of e. And then I'm going to use the power property to go ahead and bring that power down. So I have the natural log of 2 equals 0.03t times the natural log of e. Remember, we talked about previously the natural log of e is equal to 1. So this is basically saying the natural log of 2 is equal to 0.03 times t. Now all I need to do to solve for t is to divide both sides by 0.03. And then this is going to cancel. So now we can approximate the value of t using our calculator. We just do the natural log of 2 and then divide by 0.03. You can see that gives us 23.1 approximately when we round to the nearest tenth. So we have about 23.1 years before she goes from 1,500 to 3,000 at an interest rate of 3%. So now you can go ahead and pause the video and try doing this example on your own. So here we have a computer virus that's spreading at a continuous growth rate of 10%. So we're going to use this formula, this n equals n naught e to the kt, to model that continuous growth. So the value of n naught is 40. That's where it starts. 10,000 is the final amount. And then 10% we convert to a decimal. So that's 0.1. That gives us the equation 10,000 equals 40 e to the 0.1 t. Go ahead and divide both sides by 40, which gives us 250 equals e to the 0.1 t. Go ahead now and take the natural log of both sides since it's the base of e. And then we bring down that zero point 0.1 using the power property. So we can divide both sides by 0.1 to get t by itself. When we do this on our calculator, we're going to do natural log of 250 divided by 0.10, and that gives us approximately 55.2 minutes. So remember, exponential equations can be used to model many real-life situations. If you have an unknown value in the exponent, you can use logarithms to determine the missing value.